Hi guys, I'm going to go over the number 1 of the quiz that you took on the 11th. That quiz was mostly about experimental design, and the part B was about type 1 and type 2 error. And I feel like experimental design is something that you could have as notes, but still it needs you to apply that knowledge, and it requires a high level of a communication skill. So I feel like this is something that could be possibly on this year's exam. So there are 4 parts to a well-designed experiment. So first thing is a control, second thing is a randomize, and replicate, and then blocking. So blocking is optional, but those first 3 must be met in order for you to say that it's a well-designed experiment. So the control comes with having like a control group, some kind of like a baseline so that you can actually control group comes from that you are providing a same type of environment for the subjects and individuals that you are experimenting on, so that you can distinguish the effects of the treatment that you're applying to those subjects, right? And control group is a baseline of that experiment, but it doesn't necessarily mean that you're controlling the control part of the experiment. Randomize is actually very important, just like the observational studies or like a survey that we do, because the randomization is what allows us to actually say that you can make a conclusion about the bigger population, things like that. Although for experiment, you are usually going for a cause and effect relationship. And so, but randomization usually calculates the chance variation. So that's why it's very, very important even in the experiment. And we're going to talk a little bit more about that. Replicate means that you're repeating the experiments and applying the treatments to a number of subjects. So you're not going to just do a single subject and then do an experiment and have a conclusion, right? That's what we will call it's a poorly designed experiment. Let's see. Let's look at the blocking. So blocking is kind of like a stratified sampling, but for experiments. So blocking is the same idea as a strata, but you need to be careful with that language because blocks are used for experiment and stratas are used for observational studies, surveys. Let's see. So when you have a reasonable doubt that a certain factor will affect the outcome, for example, like maybe the gender of the subjects or like activity level of the subject, or just different things that affects your subjects in experiment, then you want to do a blocking so that you can remove as much variability as possible from your experiment. It's kind of the same thing as when we do survey. Sometimes we get a bimodal distribution. It's because that they didn't consider the different like a strata, right? Because like this should be one and this should be another one. So you really should be looking at 2 different strata and then compare the distribution. So if you don't do blocking when you should have, then you might see a result that you might question, that it doesn't seem as conclusive as or statistically significant as you previously assumed. So here is another way to word what I just went through. I think you want the treatment group, blah, blah, blah. So placebo is another way of having a control group, right? Especially if you want to do blind experiment. It's blinding happens when you try to get rid of some kind of like a bias in a normal sense. Like bias in statistical is very different. So like you don't want to give a preconceived idea about people who are taking pills versus not taking pills. So like placebo are usually applied so that you can do blinding, right? Like if you give the pills to both groups, then you're using blinding because the subjects don't know if they're actually receiving the treatment or not receiving the treatment. Let's see. so I'm going to post this PowerPoint. So I think you can read about it. And we're going to talk a little bit more about the matched pair design because that was a part of your quiz question. So when you are describing an experiment or when you're proposing an experimental design, sometimes it's very helpful that you use a diagram. But obviously, like drawing a diagram will require you to write it on a piece of paper, take a picture, and then upload it, which could take time. And you can do this without using a diagram. You can explain things in words, right? So this would be an example of a completely randomized experiment, okay? So completely randomized means that you often, I think you guys prefer this method whenever you do experimental design, and that's what I wanted to go over in this video, that sometimes this is not it's not the most effective design. Like there are other designs that you should consider, especially if you consider the context. Sometimes a matched pair might be the better way to do it, or blocking, or just different things like that. But completely randomized design requires you to assign a random number. So assign a number first, and then using a random number generation, or somehow you, I see a lot of examples of drawing numbers from the hat and things like that. You randomly select a certain number of people, and then you assign them to different groups and then different treatments, and then you measure whatever the result and you compare them, right? That's what completely randomized design is. When you have a blocking, then before it goes into group 1 and 2, you are going to separate them into 2 blocks first, and then you're going to use a completely randomized assignment, okay? So completely randomized design is part of the block design. So that's why, because randomization is an important part of the design experiment, that's why either you do block design or not a block design, you are going to see randomization in somewhere. All right, so matched pair. I know when you see matched pair, you're going to think of t-test, right? A matched pair is a 1-sample t-test. It's not 2-sample t-test. So you might be wondering, how is a pair data different from matched pair? So matched pair is you are matching them and then you're finding a difference of the two. So you really, in reality, you have just one set of data, whereas paired data, when there's no word matched in front of it, you're looking at 2 sets of data and you're going to do 2-sample t-tests. Okay, that is the main difference when it comes to matched pair and paired. So let me read an example here. A study is instituted to determine the effectiveness of training teachers to teach AP statistics. Pre-test and then a post-test. So that it's individual teachers are getting 2 treatments, right? I mean a treatment, and then you're seeing it before and after. So that is a classic example of a matched pair test. And what's important, as you can see, is that they are measuring before. So through pre-test, you're measuring before the treatment, and then you are given the treatment, which is the program of training, right? And then the post-test measures the after training result. And then they explain how they're going to get the data, which is subtracting pre-test from post-test, and then you're going to do the t-test. Okay, that will be how you write this example. You can read about the second example, and again, this part is not about the matched pair, but it's about the paired data, and that you need to distinguish between the two. All right. So blinding, we talked about it a little bit. So there's a single blind and double blind. Single blind is that one of the two, which is the person who is receiving, so the subject, versus someone who is evaluating the result. So one of them doesn't know which treatment was applied to the subject. And when it's a double blind, that means both of them don't know that which subject got which treatment kind of thing. So it kind of gets rid of the preconceived ideas either the administrator has or the subject have by receiving that treatment. Confounding and lurking, I'm not going to go into in depth here in this video, but I think it's something that you should read about before you go ahead and take the exam, because you get often confused about the confounding and lurking, and you don't have to emphasize this a whole lot, but it would be nice to have a little note so that when they do ask about it, you can refer to that note quickly. All right, so this is the actual question. I've seen basically I don't know how many students we have here. Only one person didn't use a completely randomized design. And as you can see here, it says this is not a good choice, okay? What that means is that you are not gonna get a P partially correct for the part A, but it depends on how well or how poor your answer is constructed. When the score is being rounded, remember that I said that there is no 3.5. You have to either round down to 3 or round up to 4. If you chose completely randomized design, you probably got 3, not 4. And that's what happened to a lot of you on this quiz, because you got 3.5. And almost all of you use a completely randomized design. So then I rounded down to 3 instead of 4. Okay, so that's the only difference you make, and maybe that's a big consequence for you. So here I talked about pair design, which is having a 2 independent set of data, and the match pair is you are making as a 1 data. So all 3 of them could earn E, but it depends on did you make a mistake on part B or not, okay? So one thing that I noticed that you guys didn't do is indicating that you measured, okay? Simply saying comparing, I don't think that will merit this E in the section 2. You guys did show that you have a treatment, but there was no explicit statement that you measured what, right? It is very important that you write it in context. I need you to write it again, even though the problem is stated, okay? That's something that we talk about all year long. You have to say that measure, diastolic blood pressure before and after the treatment, if that's how it is. And then compare those 2 results from the different groups. And depends on which design you chose, how you compare might look different, okay? So I want you to read about these answers and ask me questions later on through email or comments if something didn't make any sense, okay? All right, so type 1, type 2 error, you guys have a definition right. I didn't see any mistake on writing the definition, but I saw some of you didn't write it in context. You might think what you wrote was good enough for the context. No, when they say in context, you need to be very, very explicit, okay? So I want you to read about this, especially if you're still confused about the power and alpha and the relationship between the 2. I'm not going to go over this because that wasn't the part that this question focused on. But I think I share the link that the AP statistics video on YouTube by College Board. I can kind of move it up so you can see it again. But type 1, type 2 error and understanding the concept behind it, I think is very important, because that's one of the more complicated concepts that was seen in this subject. All right, so this same thing. So part B. Again, you guys did a great job of writing the definition, but some of you were very weak in giving the context, okay? And it didn't matter whether you chose type 1 or type 2 error was more significant, more serious, as long as you had the right justification for your choice. Writing a consequence for each error was also part of the scoring, and some of you forgot that, or you kind of went from the generic definition to the consequence, and so then you didn't score right for section 1 because you have to write in context of the type 1 and type 2 error, and you failed to do that. So again, it seems like a little thing, but they don't like using a generic language. If you're writing it, if you don't give enough context, they're gonna just grade it down. So please avoid that mistake, because I think those are more common mistakes that you guys always make that you shouldn't be making, because you know better than that.